I'm still going. Page 42.
Hang
on. On the 12.
And now we're on skateball.
Alright, complementary angles.
Speaking of people, we got my day yesterday from period 6 onwards got all.
Right.
Did you get it?
Like my day
Did you end up
from
sorry?
period 6 onwards.
Hey,
Oh, I have a nice book for maths.
you what? So you got a
My
nice book
extension,
from
I have a nice book for maths.
Period 6. Study and everyone went to follow.
Alright, bang.
Hey, what did that guy say?
File. Stop. Meter. Thank you. Alright, so looking at complementary angle. Alright, so we've got the diagram here. So you can draw straight onto the diagram in your theory note. Alright, so we've got theta here. Alright, so let's label those three sides of that triangle, okay, with respect to theta. Okay, so we need to label the hypotenuse, opposite side, and the adjacent side. Okay, so we should know opposite the right angle is the hypotenuse, opposite the marked angle is the opposite, and the adjacent side is the side left over, which contains both those angles. Alright, so we've got sine, cos and tan. We also have cosec, so we did this on Friday. We did sec, and we did cot of all those angles. Let's have a look. Okay, so reference to that triangle, so we've got sine theta. Okay, so we should know these ratios, opposite over hypotenuse. I need to do, first before we do that, let's label the following please. Let's treat it like Pythagoras, so we've got C, A and B. So that'll equal B over C. Alright, so let's treat it like Pythagoras theorem and put the variables there and we'll label accordingly. Alright, so cos theta, so we should know these ratios. You've done the trig the last couple of years as well. Alright, so cos theta is going to be adjacent over hypotenuse, which is little a over little c. And tan theta is opposite over adjacent. Okay, and the letter is B on A. Alright, now remembering our three new ratios, these are called the reciprocal ratios. Okay, and take the third letter of each of those, and that will give you what you need to take the reciprocal of. Okay, so S is the third letter for cosec, so we're taking the reciprocal of sine. So basically, we need to flip the fraction over. Okay, so it means flip both those fractions over there. Okay. Alright, for sec, which is short for secant. Alright, C is the third letter, so that's referring to cos. So normally cos is adjacent over hypotenuse. When you take the reciprocal, you get sec, and you get hypotenuse over adjacent. We also need to flip that fraction over, C over A. And cot is the reciprocal of tan. Tan is normally opposite over adjacent, so we need adjacent over opposite for cot, and we flip this fraction over, so we get A over B. Right. So, also we have 90 minus theta. Let's have a look at this. Sine of 90 minus theta. looks like I left you a bit of room in your notes so you can write it straight in there. Alright, so 90 minus theta is referring to this angle up here. So we did our angle sum of triangles, so you've just done your geometry component of your exam. Okay, so this angle value will be 180, take away 90, take away theta, and when we simplify that, it becomes 90 minus theta. Okay, now we're going to keep those three variables there. Alright, however, like we did last lesson as well, this will change the other two, opposite and adjacent, because referring to that angle, that is now the opposite, and this angle, let's say, is the adjacent. Okay, so we're still going to leave it as A, B, and C in those. Alright, so sine of 90 minus theta, so same ratio, opposite over hypotenuse. Okay, so the red referring to now, so we've got A over C. Alright, so we have a sine here which is B over C, and then we have the other angle in the triangle with an expression relating to that, we have now A over C. Right, because 90 minus theta is the adjacent side over the hypotenuse. Okay, so now looking at the red, is now equal to B over C. Right. Opposite over adjacent is 10. And looking at the red, the opposite which is B, and adjacent which is J. Okay, so remembering our our reciprocal, you take the third letter, and that will tell you what you need to take the reciprocal of. Okay. So cosec, which is reciprocal of sine, so we get hypotenuse over opposite, which is C over A. Okay, because flipping these two fractions over. Okay, sec, which is hypotenuse over adjacent, which would be C over B. And cot, so we've got adjacent over opposite, so we have B over A. Alright, do we notice anything? Yes, you do. You're not telling me, or no, you're not actually noticing?
What? The things is.
Alright, what do you notice about this one? And this one?
Oh, sine, cos, equal the same thing.
Yep. Okay, so that's number one. So label this in your note. Number one. Number one. What else?
It shows it all here.
Yep, but can you see the connection here though? Good. Okay, because theta is equal to sine of 90 minus theta. Alright. Tan of theta equals what on the other side? Okay. Cot. The tan of theta is equal to cot of 90 minus theta. Cosec of theta is equal to what?
Sec. Yes. Sec of the 90 degrees minus theta.
Okay. Sec. Sec of theta equals what?
Cosec.
Cosec of 90 minus theta. And cot of theta. Okay. A over B. Oh,
No, you haven't. It's all the same.
It's supposed to be A over B.
should be A over B here. And that'll give us 6. Okay. So, from that, we have the results in your table. Okay, so they're summarised right there. Alright. So this is one of only well, compared to the whole topic, a small handful of what you are learning this topic. That's new that you haven't done before. So let's look at some examples incorporating that. So that example A. Oh, sorry. F. Up to. So that's X. Alright, so cos of 60 degrees is equal to sine of X. Alright, so we're solving for the variable. Okay, by making the connections over there to what's happening over here. So, cos of theta is equal to sine of 90 minus theta. Okay, so we made the connection. So theta equals 60, then sine. So theta equals 60, cos of 60 is going to equal sine of 90 minus 60, which is sine of 30. Okay, so cos of 60 is the same ratio as sine of 30. Okay, so X is equal to 30 degrees. G, the tan of 55 degrees is equal to cot of Y. Okay, so these are called complementary angles. So actually find the property, the tan of theta is going to be cot of 90 minus theta. Okay, so there's your connection. The tan of 55 degrees is going to be cot of 90 minus 55. Okay, which is cot of 35 degrees. Okay, so that means that variable, which is the y, will equal 35 degrees. Okay, so I'm following what we're achieving here in terms of the maths involved.
Yep, kind of a little bit.
Kind of, a little bit.
Yeah.
H, cosec 75 degree is equal to sec of z. Okay, this is pretty much, this is a very building up exercise, okay, so the skills that you're doing here will be more apparent for what you need to use them for in a future concept that you haven't learned before. Alright, so let's make the relation. So cosec of theta is going to be sec of 90 minus theta, okay? So if you forget what they're equal to, okay, I've just proven it. I've just proved it, okay? Draw your right angle triangle, set it all up, okay? So you have a means to work it out, okay? Which is what I'm pretty much teaching this topic about, particularly when we do extension through your extensions. Alright, so cosec of 75 degrees is going to be sec. So with theta, the variable, is 75. Alright, so we substitute theta for 75. So 90, take away 75, okay, which will be sec of 15 degrees. Okay, Okay, and then last step is to set your variable, z equals 15 degrees.
No, oh my goodness. I was like, oh, you found it away. Oh.
It was a really good documentary though.
Wow, my eyes.
But
I'm trying to see myself. Come on. Oh yeah, like that's, it is very vigorous.
Well,
I was not,
well, I'm not.
I was not expecting it. I was just chilling. Take me out and then bam, Kyle said
It was Chrissy Long. Heroin addict. The married,
so much better.
the married coach.
Alright, example, next set. So, I. Alright, so we just looked at variables and now we're looking at simplifying. So, you looked at completing for the variable, now we're going to simplify. So, sine of 20 degrees, take away cos of 70 degrees.
We just check on the calculator.
Okay, there's one or two things we can do here. Right, we can change the sine to a cos, or we can change the cos to a sine. Okay, we're going to do the latter. Right, so it's going to be sine of 20 degrees. So, cos of theta is going to be equal to sine of 90 minus theta. Okay, so I'm going to rewrite this cos as a sine. It'll be 90, take away the value of theta. So doing the connection with what we've done over on that side. So theta is 70. Okay, the cos of theta is equal to sine of 90 minus theta. Okay, so sine 20 degrees, take away sine of 90, take away 70. So we have sine of 20 degrees, take away sine of 20 degrees, which equals 0. Okay, so if you put this in the calculator, if you put sine of 20, take away cos of 70 into your calculator, it'll come up as 0.
What about 0? You're so good at drawing circles, but then there's just that 0.
No OCD is kicking in. You change it.
No, I love it. Keep it that way.
J, 10, 65, take away cot of 25. Now, if I had done this as a cos, if I changed the sign to put cos, I would get the same answer eventually, okay, which is represented by different variables. Alright, so 10 of 65, I'm going to change the cot to a 10. Okay, so look at my relation, cot of theta is equal to 10 of 90 minus theta. So 10, 65, take away 10 of 90, so this is theta here, the cot of theta is equal to 10 of 90 minus theta. So replace theta with what I've got in my expression up there. 10, 65, take away 10 of 65. And I hope Amanda's more satisfied with that right there.
Yes, it's lovely.
Good.
Thank you. Right, do they all end up being 0?
Thing, eh? Alright. Okay. Sec of 80 plus cosec of 10. Sec of 80, take away plus cosec of 10. Alright, so we're looking at changing that sec to a cosec or that cosec to a sec. Alright, doesn't matter. Alright, as long as you're consistent. So I'm going to change the cosec to a sec. Okay, so cosec of theta is equal to sec of 90 minus theta.
Hey man, get a broom we can have.
Good broom. She's rich, she might even have a leaf blower.
No, I have no personal assistant.
Oh, can you have it?
Alright, so what is sec of 80 plus sec of 80?
Sec 160. Sec 160.
Would it be,
Is it just 0?
Hey?
Is it just 0?
Nope.
is it one?
Hey?
One?
Nope.
What are you trying to find?
Well, how do I simplify the expression sec of 80 plus sec of 80?
Second of 80.
Hey?
2 sec 80?
2 lots of sec 80.
Well, that's a good bridge.
Okay, you got adding like terms. Go back to your algebra now. Okay, sec 80 was a banana. Okay, you got a banana plus a banana, which equals 2 bananas.
Double pen? No, okay.
Amazing. Funny how maths works out, eh?
Yeah. Yeah, we use fruit or
What did you say?
If she wants to be innocent, don't tell.
Alright, were there any questions on that?
Too deep.
Put the sugar away, please. Put the sugar away, please.
Oh, there's more. Whoa.
Whoa.
Alright, 3 more for this section. Alright, so stepping up next level.
Just
L.
a little bit.
Alright, so now we have sine of x plus 20. The bond base per numeral, 20 degrees, which equals cos of 55 degrees. Okay, so we've looked at complementary angles, so we've looked at what things are equal to in relation to each other in the right angle. Alright, so sine of x plus 20 is going to be equal to cos of 55. Now the relation cos of theta is going to be sine of 90 minus theta. Okay, so we need to change this cos to a sine. Just like when we did solving equations involving index, you have to get the base the same before you can set the index equal and solve that equation. Same principle, okay? So the base is down your sine. Alright, the sine of 90 take away 55. It's going to be sine of 35 degrees. Alright, so sine of x plus 20 is now equal to sine of 35. And when that ratio is correct, sine, cos or tan, as in they're the same on both sides, then what's after, the angle after it's referring to must also be equal. So therefore x plus 20 is equal to 35. Okay? So x is going to be 15 degrees. And there we go, have another application of equation. Alright? About 90% of your course is algebra skill and solving equation. Okay? Which is all chapter 2, chapter 3. Alright, how well you go in the course will determine on how well you can do your algebra skills and your equation skills. Okay, because they will come up time and time and time again. Right, M.
No.
Right, cosec of 2x take away 56 degree, which is equal to sec of 28 degree. Alright, so with these equations, so the examples we've done before, I could have changed the sine to a cos, and I would still get the same answer, okay? Here I could have changed the tan to a cot, and again, I'd get the same answer, alright? I could change the sec to a cosec, Alright, I won't get the same answer because this is the terms of sec, but you'll have an acceptable answer in relation to cosec. Alright, so you can do either side of that. When you have an equation here, I'm not going to change this cosec to a sec. Okay, because I don't want to introduce another variable, another part of the equation here. Why do I need to? Okay, when it's nice and easy to change this side and keep this as it is. Okay, so this equals cosec. So the relation is sec of theta, which is cosec of 90 minus theta. That's the rule that we just covered. So this will equal 90, cosec of 90, take away 28. 62 degrees. Okay, so again, when I have the base, as in the trig ratio the same, right, so a cosec on both sides, therefore the angle they're referring to must also be equal. Right, so that means 2x take away 56 is equal to 62. Okay, so that equals that. Right, two-step equation, so 2x is equal to 6, and therefore x is equal to 3.
It's addition because that's a negative 56.
So-
2x is 118, sorry. 150. There you go on the ball.
Next.
I really like to rock and see before we drop the book.
I'm not trying to do that. No, no one dropped. You dropped to general. Really?
Right, last example, n. So we have cot of x plus 24, which equals to tan of x. Right, we've got a variable on both sides now. What am I going to do?
Change the 10 because it's only one variable, one thing.
So we're going to change that tan. Right, so the relation for tan theta, which is going to be cot of 90 minus theta. Okay? And now theta is x. Alright, so cot of x plus 24 is going to be cot of 90 take away x. Okay, because tan theta is x, which will be cot of 90 take away x. Alright, so the first step is we've got the base the same. Alright, probably not called the base, but in relation to what you have covered before. So therefore, the equation is x plus 24 must equal 90 take away x. Now the three-step equation, so. Right. So, add x to both sides. So we have 2x plus 24, which is 90. Take away 24, so 2x is equal to 70, 66, and therefore x is 33. Right, question? Alright, we're going to stop there today, because that was all new. Okay, so that's what you need to learn. You can derive it yourself by drawing a right angle triangle, setting theta, setting variables in triangle, then go 90 minus theta, and work out what's equal. Okay, or otherwise you need to learn it all off by heart.
When it changes, is it always just the one that it's changing to and then 90 negative theta?
Yep, pretty much. Okay, so basically you're setting the ratio equal, so whether it's sine, cos, tan, cosec, sec, or cot, set them equal, and then the angles equal. Right, you have about 18 minutes. You can, that's now exercise 9.1.
9.
6.1. So,
So can I, can I get this sandwich please before it contaminates
don't make a mess.
with really nice food?
Now, I have covered 6.2, 6.3 and 6.4. The 6.2 was finding the side, 6.3 I think was also finding the side, and 6.4 was finding the angle, okay? So, you all have some form of work to do.
Oh, there's yogurt on my sandwich.
Don't forget your chapter 4 exercises are due Monday. Alright, 18 minutes. Off you go.
Still have plenty of